Section 3.4 is titled Dividing Rational Numbers. A reciprocal, or reciprocals, are two numbers whose product is 1. And we find the reciprocal of a number by flipping it when it's written as a fraction. So let's practice finding the reciprocal of each number. Remember, you are flipping the fraction. So for number 1, we have 7 over 16. So the reciprocal, we take the numerator and put it in the denominator, and the denominator and put it in the numerator. We get 16 over 7. Example 2, negative 6 and 1/3. We need to write it as an improper fraction first, so we need to candy cane. 6 times 3 plus 1 is 19 over 3, and remember it is negative. And so when we take the reciprocal, now we want to flip it. 3 over 19. And if your original number is negative, the reciprocal is also negative. So you try the next two on your own. So pause the video here, try 3 and 4, and then check your answer. To find the reciprocal of negative 7 over 9, it would be negative 9 over 7. The reciprocal of 2 and 2/12, when we candy cane, 2 times 12 is 24, plus 2 is 26. So we have 26 over 12. And we actually should reduce that fraction first. Both of those numbers are divisible by 2, so we get 13 over 6. Now when we take the reciprocal, 6 over 13. Hopefully you got those last two right, and if you didn't, you can see where you went wrong. So, dividing fractions. To divide by a fraction, it means to multiply by its reciprocal. So if we look here, we have a over b divided by c over d. Well, that's the same as a over b times d over c. So instead of dividing by this fraction, we end up multiplying by its reciprocal. C over d becomes d over c. So in the example here, we have 4/9 divided by 3/5. Dividing by a fraction is the same as multiplying by a reciprocal, so 4/9 times 5/3. Now we just use our rules for multiplying fractions from last week. 4 times 5 is 20. 9 times 3 is 27. And then we check to see if we can reduce. The only numbers that go into 27 are 3, 9, and 27. None of those numbers divide into 20, so this is our answer. So let's look at some more examples. Find the quotient and write it in simplest form. We have 1 over 9 divided by 5 over 12. So multiplying by, or dividing by a fraction is the same as multiplying by its reciprocal. So the first thing we want to do is change the problem to multiplication and flip or find the reciprocal of the second fraction. Now when we multiply, we get 12 over 45. Both of these numbers are divisible by 3, so when we reduce the fraction, we're dividing by 3, and we get 4 over 15. Three sevenths divided by 8. Now here 8 doesn't look like a fraction, but we can make 8 look like a fraction by putting it over 1. So now multiplying by the reciprocal, we have 1 over 8. Multiply across the top, multiply across the bottom, and then we check to see if we can reduce. 56 is not divisible by 3, so this is our final answer. Here we have 1/3 divided by 7/15. We want to multiply by the reciprocal, so that's 15 over 7. Multiply across the top, 1 times 15, across the bottom, 3 times 7. We get 15 over 21. Hopefully you see that both of these numbers are divisible by 3. so we get 5 over 7. Remember, another way to solve this problem, for those of you that like to cross-cancel first, we could have canceled the 3 with the 15. The 3 becomes a 1 because 3 goes into 3 once. The 15 becomes a 5. 3 goes into 15 5 times. 1 times 5 is 5. 1 times 7 is 7. And you see you get the same answer. Okay, we have 5/8 divided by -3/4. So first thing I want you to pay attention to here are the signs on these fractions. What is your answer going to be, positive or negative? Hopefully you're saying negative. 5 over 8 times a -4 over 3. Positive times a negative is going to be a negative. 5 times 4, 20. 8 times 3 is 24. Both of these numbers are divisible by 4. So we get -5 over 6. Here, if you'd like to pause the video and try this one on your own, -6 over 7 divided by 12. So if we rewrite this first, we write 12 over 1, so we can write the whole number as a fraction, so that when we multiply, we can multiply by the reciprocal. So this gives us -6 on top, and 7 times 12 is 84. And what we need to check is what number goes into 6 and 84. You might start with 2, since 84 and 6 are both even, but 6 actually goes into 84. So if we divide the top and the bottom by 6, we get a -1 on top. And remember, you can write the negative out in front, you can write it up on top with the 1, you can even write it on the bottom, just as long as you have a negative sign somewhere on that fraction. And 84 divided by 6, if you're not sure, you can do some side work. So 6 goes into 84 14 times, so we get -1/14. Here's an example with mixed numbers. This is just like it was when we were multiplying. We want to change the numbers to improper fractions. So we want a candy cane. Don't forget that that one was negative. So we get 12 plus 2, -14 over 3 divided by 28 over 9. But now when we multiply by the reciprocal, it becomes 9 over 28. So we multiply across the top. 14 times 9, you might have to do some side work. That's 126. The bottom, we get 3 times 28, which is 84. Remember, our answer is negative because it's a negative times a positive. Now we have to start checking what numbers go into 126 and 84. You may start with 2. They are both even. Half of 126, that's 63. Half of 84, I'm dividing them by 2, is 42. And now we still need to reduce. 63 and 42, I'm not sure if you see this, but they're both divisible by 7. 63 divided by 7 is 9. 42 divided by 7 is 6. That's negative again. But now you can see that 9 and 6 are both divisible by 3. So we get 3 over 2, -3 over 2. Now, I know that a lot of you don't like to cross-cancel, but cross-canceling ends up making this problem so much easier. If I rewrite the problem up here, 14 over 3 times 9 over 28, and it's negative. Now watch what happens. 3 goes into 3 once, 3 goes into 9 3 times. 14 is actually half of 28, so 14 goes into 28 twice, and 14 goes into 14 once. So now what I have is -1 over 1 times 3 over 2. so I get negative 3 over 2. It's a lot simpler if you cross cancel. You don't have all this reducing to do. But again, if you're not comfortable doing the cross cancel method, you can always do it this way. You just have to make sure that you're reducing properly. The last example I want to talk about is an example where we're using variables, because just like with numbers, we can also reduce fractions that have variables in them, and I'll show you how we do that. First of all, just think of this problem as two fractions being divided. That means we want to multiply by the reciprocal. So we're going to leave the first fraction as it is, and we're going to flip the second fraction and change our sign to multiplication. Now we want to multiply across the top. What is 5 times ABC? Well, it's just that, 5ABC. How about on the bottom? 3AB times 15. Remember, we've done this before. We just multiply the numbers. 3 times 15 is 45, and we tack the A and the B on the back. We just kind of smash it all together. But now we have a fraction that can actually be reduced in a few different places. First of all, the 5 and the 45 need to be reduced because 5 goes into 45. So if we reduce those, 5 goes into 5 once, 5 goes into 45 9 times. But now we need to look at the variables, because whenever you have a variable in the numerator and that same variable in the denominator, they also cancel. It's kind of like having 2 over 2. Same with A over A and B over B. Now we've cleaned this up quite a bit. On top we have a 1 and a C, so 1 times C, and on the bottom we have 9. So look at the original problem, what it looked like, and look how we've simplified it all the way down to C over 9. Remember, we don't have to write the number 1 in front of a variable. So make sure you understand how this is done, canceling variables just like we can cancel numbers. And in class, we'll work on worksheet 3-4.